There's a black hole so large that our entire solar system could fall inside it, and we wouldn't even reach the edge. Not just Earth, not just Jupiter, even Neptune's orbit would disappear. And the terrifying part? This object formed when the universe was still young, and scientists still don't fully understand how something this big was even possible. This isn't just about size. It's about a structure so extreme it bends space itself beyond what our models can comfortably explain. This object has a name, TON 618. TON 618 is not simply a black hole, it is a quasar, a galaxy whose center outshines entire star systems because of the black hole within it. The light we see today began its journey billions of years ago when the universe was still in its early stages of structure formation. At its core lies one of the most massive black holes ever measured, tens of billions of times the mass of our Sun, compressed into a single gravitational boundary. Numbers of that scale blur together, so the mind needs structure. If TON 618 were placed where our Sun is, its event horizon, the point of no return, would stretch beyond Neptune's orbit. The entire architecture of our planetary system would sit inside it. This is not symbolic language, it is orbital mathematics. And that is where scale becomes physical. There is a common misunderstanding about black holes. They are often imagined as aggressive cosmic vacuum cleaners pulling everything inward. That image is incorrect. Gravity depends on mass and distance if the Sun were replaced. With a black hole of the same mass, Earth would continue orbiting normally. The difference is not in the type of object, it is in the amount of mass. Concentrated at the center, TON 618 contains roughly 66 billion solar masses. For comparison, the black hole at the center of the Milky Way contains about 4 million. That difference is not incremental, it is transformative. Mass determines gravity. Gravity curves spacetime. Spacetime governs motion. When mass increases to this level, geometry changes at a scale that affects entire galactic systems. The event horizon of TON 618 spans light days. Light itself, traveling at 300,000 kilometers per second, would need days. To cross that boundary, our solar system spans light hours. The comparison is not dramatic. It is geometric. And geometry does not exaggerate. TON 618 shines because it is actively consuming matter. Gas spirals inward, forming an accretion disk that rotates at extraordinary speeds. As material falls deeper into the gravitational well, it heats through friction and compression. Gravitational energy converts into radiation. This radiation is what makes a quasar visible across billions of light years. The black hole itself remains dark. The brightness comes from matter in its final orbit, before disappearance. Quasars were more common in the early universe. That period was dense, chaotic, and rich in gas. Galaxies were colliding more frequently. Matter flowed inward more efficiently. Under those conditions, black holes could grow rapidly. Yet even within those parameters, TON 618 pushes the limits of expectation. Standard growth models allow black holes to increase mass through steady accretion and mergers, but reaching tens of billions of solar masses in less than 1 billion years requires extraordinary efficiency or unusually massive initial seeds. Physics remains intact. But the early universe appears to have been capable of assembling structure faster than once assumed. Gravity, given enough density and time, becomes an architect of extremes. It is tempting to think of TON 619 as an isolated anomaly. In reality, it resides within a galaxy, one likely massive beyond easy comparison. There is a known relationship between the mass of a galaxy and the mass of its central black hole. This correlation suggests coevolution. As galaxies grow, so do their central gravitational anchors. But the relationship is not passive. When a quasar ignites, at full intensity, it releases enormous energy outward. Jets and radiation can push gas away from the galactic center. Star formation can slow. Entire regions can be reshaped. The black hole does not merely sit at the center, it participates in the evolution of its host. The solar system comparison now deepens. Yes, our planets would fit within its event horizon. But beyond that boundary lies a gravitational sphere of influence, extending across thousands of light years. The event horizon marks escape velocity. It does not mark the end of influence. Geometry creates consequence, and consequence scales upward. TON 618 formed when the universe was young, less than 1/10 of its current age. At that time, the cosmos was denser, matter was more tightly packed, galaxies were assembling from primordial fluctuations left over from the Big Bang. Under those conditions, some black holes may have formed through direct collapse of massive gas clouds, others may have grown from the remnants of the first generation of stars. The exact sequence remains an area of research. Observations refine mass estimates, simulations test formation pathways, uncertainty persists, because the events occurred billions of years ago. But the existence of TON 618 is not speculative. Its light reached us, its spectrum has been measured, its mass has been estimated. Using established techniques, the solar system feels vast to human perception. Neptune orbits at distances that already stretch imagination. Yet around TON 688, that entire structure would exist, inside a boundary defined purely by gravity and escape speed. This realization does not require fear, it requires perspective. The universe permits extremes, it builds them through simple principles, repeated across immense spans of time. Gravity gathers matter, matter curves space, space shapes motion. From those rules emerge galaxies, stars, planets, and occasionally structures so large that our entire solar system becomes a unit of comparison. TON 618 is one of those structures, and its existence reminds us that scale in the universe is not limited by familiarity, only by physics and time.